These are very promising, but they're not mature enough for us to look at. We looked at even more exotic things. If you watch Star Trek, you know they use antimatter. This was from a study that NASA did a decade ago, and it said that antimatter could provide the necessary fuel to go 20% the speed of light. The trouble is we can't make very much of it, we can't store it. We're off about 10 to the 14th in terms of making it and storing it, so we abandoned that. So we went to a very old technology. A sailboat uses power it finds rather than carrying its fuel with it. And I said this is a very cool idea. Johannes Kepler in 1610 suggested sailing in the seas of space in a letter to Galileo. Now this has been done. This was an experiment by the Planetary Society, a privately funded effort that demonstrated you can use light to push a light sail. The trouble is that light isn't very concentrated. We can't get the speeds we want. So what we decided to do was we would make a much smaller spacecraft, and we would use a laser, a very powerful laser, to send the spacecraft at the speed by using light pressure from the laser. And I'll tell you a little bit about that. Now, it's a really big laser. The laser has to be to 100 gigawatts, and it's a square kilometer in size. Alpha Centauri is in the southern hemisphere, so this has to be in the southern hemisphere. We looked at putting the laser array in Chile. I did neglect to tell the Chileans, so I was summoned to talk to the president of Chile, who now likes it. So this is something we can do perhaps in a few decades. The two key things are to make a spacecraft really small. And microelectronics has enabled us to do that, and I'll talk a little bit about that. And the second is ability to put literally millions of lasers together. Now today, if we did this, it would cost trillions of dollars. On the other hand, we see that Moore's law, that every few years the cost of lasers is going down a factor of 2, and the power is going up a factor of 2. We looked at these and said within 15 or 20 years, we should be able to build a laser affordably, something like $10 billion US that could push these sails. Now, the second question is spacecraft. This is the spacecraft, typical communication spacecraft. It weighs several thousand kilograms. We couldn't possibly push that fast, but we think we can make a much smaller spacecraft. Indeed, if you have a digital watch, the chip in that watch does much of the same thing that a spacecraft does. Indeed, so we put together a spacecraft on a chip. I brought one with me. I have a spacecraft in my pocket. This is a prototype. We launched one last year about this size. We'll launch more this next year. This is a revolution in spacecraft. Over the last 2 decades, we went from 1,000 kilograms to 1 kilogram. We think we could go in the next decade down to a gram. This is a major new development. Indeed, as I said, we launched one of these last year. We actually launched it on Latvia's first satellite. Again, we neglected to tell the Latvian government, so they asked us to come and talk to them as well. But the technology is there. So the idea is to connect this chip, that we call a star chip, to a light sail, and we call that a nanocraft. Our schedule is over the next 5 years. We have $100 million US to do the basic research. If that works, we would like to build $1 billion privately funded prototype. And then if that works, we would begin constructing in 15 to 20 years the system that can send within about 30 years these chips to the nearest star system. So within about half a century, we would have our first visit to another star system. We have just chosen about 13 contracts for the first set of studies. We have released a request for proposal for the sail material, for the light sail, and the other key question is how to communicate. We're releasing that in a few months. Now, again, the final question is there life anywhere? The We don't know how life began, although there's a number of ideas. We think it might be created in an ocean that, in contact with volcanic activity, creates life. We also think that life can be spread between different planets through impacts of asteroids. And finally, we think it's maybe possible that life can be spread between the stars by something called interstellar panspermia, but we don't know any of this. Much of the effort is focused on Mars in our own solar system. We still haven't found evidence of life, but there may be below the surface. There is ice of what used to be oceans on Mars that's below the surface. In fact, there's a lot of ice. If it was melted, it would create oceans several hundred meters deep on Mars. But there are other places in the solar system. So one of the things we are looking at is a privately funded mission in the next few years to perhaps this object. This is one of the moons of Saturn. It's an inner moon called Enceladus. It's an ocean world. It has an ocean that has ice on top of it. But the Cassini mission, which was completed a few months ago, showed that there's plumes of ocean water going into space. And we've seen evidence of simple carbon molecules. So this may be a place, if we can go sample that material, we can find evidence of life. One of the moons of Jupiter, Europa, also has plumes of water. And this is another place that we're looking at going. This is Venus. This is almost the Earth's twin, other than the surface temperature being about 500 degrees centigrade. But up in the atmosphere, at about 50 kilometers above the surface, there's a cloud layer that may have life. And we're thinking about sending a probe there. In fact, it's been designed by various space agencies to fly a balloon in these clouds and look for life. We don't even know if there's life in the upper atmosphere of the Earth, so one of the things we're looking at is funding efforts to look there. And finally, there are other objects in the solar system, small objects. This is the dwarf planet Ceres in the asteroid belt. The Dawn mission just completed a study there and found there could have been evidence for life at one time. Now turning to the other star systems, the nearest star system is Alpha Centauri. As I said, it's 4 light years away. It's the second brightest star in the southern sky. It consists of 3 stars. 2 of them are about the size of the sun. One's a little bigger, one's a little smaller. The third one is a very small star, one of these red dwarf stars. So it's a much different star system than ours, but it could potentially have planets. Indeed, we made our announcement we're going to go there before we knew there was any there. But a few months after we made our announcement, the European Southern Observatory announced that that small star actually has a planet that's potentially is habitable to the size of the Earth. Indeed, they already have a picture of it, so I guess we don't have to go there. Artists can do wonderful things. To look for finding planets around the stars that are like the sun, we have a program with the European Southern Observatory. We will begin observing next year with this telescope, which is a very large telescope in Chile, to see if we can directly image the planet. But around the world, there are several programs with even bigger telescopes. This is a 39-meter European extremely large telescope being built. Now, I'm always amused with the names of these, with the very large telescope, the extremely large telescope. I understand this was originally called the overwhelmingly large telescope, but they had a budget cut. Finally, I'd like to just close with we have an annual conference every year. We've had a number of people from Korea visiting. We hope to have more. It's held at Stanford University. This year we looked at exotic, maybe even machine life that you could look for, and other questions about advances in propulsion. But one of the things I wanted to point out, and one of the key reasons I'm in Korea is tomorrow I'm going to talk with Kari, is we're very interested in working with space agencies around the world. We have meetings every year at our conference with the leads of science and space agencies to see how we can work together. We think if all goes well, maybe in 50 years we'll have our first picture of a star or a planet orbiting another star. Maybe we're really lucky it'll even be life-bearing. If we're really lucky it's a civilization there, but probably not. So thank you. I'd be happy to here in a bit to answer your questions. Thank you.
Thank you, Dr. Morgan. Please have a seat. 안녕하시죠? 네. 자,